Hello. Is me. I'm here, and I'm going to work on my programming language again today. The kast. Let's see. I did some more shit off stream. What did I do? I changed the syntax mostly. I don't think I did anything else, but previously, if you wanted to have the struct or a tuple, I call them tuples still, with so we have tuples with unnamed fields, obviously, right? But we also can have tuples with named fields, and previously like we could do like the named fields as like name is like value, right? But that doesn't work anymore because this new syntax is dot name is 3. What did that? Similar to Zig kind of, and then instead of dot sum 1 2 3 like we had before, now we need to do a colon sum 1 2 3 to construct a variant of some type like this. I think I might want to change the colon to be something else, because we specify the types of values using double colon right now, and if I can change the double colon to be a singular colon, that would be kind of nice. I don't think it matters much, but I don't know, a single character is easier to type than a double character, I guess. But I don't know what the syntax for the variants would be then, because I needed to have a different syntax. In Rust, you just say some 1 2 3, right? But that's it's a little weird. Because it doesn't distinguish it between normal things. Versus variants. In some languages like OCaml, they make the variants to start with like the variant constructors to start with capital letter, and other things like normal functions would start with lowercase. But I don't think I want to do that either. So I choose a dedicated symbol. I'll keep it just a colon for now. But another idea would be to use the tilde, which was used for named arguments before, maybe. Actually, hold on. Let me see what do we have. Let me see what are of the variants at all. Yeah, I don't know. I think I'm out of symbols. And that makes sense for this. All right, anyway. I'm not going to think about syntax too much. What I want to do today is the new feature, which is the old feature that I had in OCaml version, which is casting. So I want to have casting here. So if I say that 1 2 3 int 32, and I want to cast this into an int 64, this should work, right? I should be able to cast values from one type to another type, and casting between the integer types is not the most important thing here. This is going to be used more for like trait like things, where I would be able, since our types are also values, right? I should be able to cast an int 32 into a trait like this, right? And that will give me the implementation of the parse trait for an integer, basically. So that's the main use case for casting, I think. So that's what I'm going to do. This is called, so when I say as, Let's see, it was previously called get impl. std syntax as no as over here, right? So I'll just call this cast, where we cast value as something else. Yo dev ninja, hello. How are you doing? How's your language doing? I mean, are you still doing it? I am also doing good. This is almost a complete rewrite, I think. With some features already being better than in the previous implementation. You had to pause for a second since other stuff came into way. Did you also play Factorio? Value as I don't know. I cast into target. This is not necessarily a trait. I can cast into types. I can also cast into some other things. Yeah, I guess. I cast into target. Sure. Check impl. I'm going to comment that. So A as B is now being parsed as a cast, a value being A, target being B, sure. Satisfactory better than Factorio? That's heresy. I mean, I didn't play Satisfactory, maybe it is. But I'm pretty sure that this is not true. Pretty sure. Convince me why making it and why you should use it. Okay, well, I'm not trying to make anyone use it yet because I'm making it for fun. That's the main reason why I am making a programming language. Bad Nintendo, hello. But there are features in the language that are, I don't know how to say it. It's going to be a language with, it's going to be an expressive language that is going to be, I don't know. Like, how do you like sell any language, like even any of the existing languages, right? I can like tell you some of the like killer features that are not present in other languages, basically, or like in any mainstream languages. Most importantly, I'm interested in like algebraic effect systems. Kind of. I'm doing it a little bit differently than like other languages with algebraic effects. But if you don't know what it is, it lets you encode properties of your program in types, right? Similar to how if you have tried Haskell, it lets you like it uses monads to make sure that the language itself is pure. So like the side effects are like done like in this weird way, you know. It makes it easy to reason about your program if the properties are encoded in the type system, basically, right? But I don't want to do the monads like in Haskell. Instead, I want to write effectful code, so the effects of your code need to be written down. For I don't know, the most simple one is I'm writing this in Rust, and I really don't like the fact that I don't know if a function is going to panic or not. Right? I want to sometimes guarantee that a function is not going to panic, and there is no way to do it in Rust. And that's just one small example. Right? And then there are the, like other things. I'm trying to make the language with a tiny core, which is supposed to be extensible also. One of the features is the extensible syntax. So over here, this is the standard library, and standard library is what defines the syntax of the language. The syntax of the language is not hard-coded. If you really want to, there is an option to define your own operators, define your own like other syntactic constructions in addition. Like it's yeah. Like one of the examples of extensibility of the language. One thing which came into the way was a Twitch extension with which you can adjust the cost of a channel point rewards based on your heart rate. Huh? Like when you're streaming? I don't think I saw your stream. Did I? Maybe you stream while I'm sleeping or something. Have a run track time, how many lines it's processed to generate your own console log error results that pinpoints where data stopped reading at. Have a run track time. Hold on, I'm having trouble reading this sentence. Have it run track the processing time and number of lines processed to generate the console log errors that identify where data reading stopped. Track the processing time and number of lines processed to generate console log errors. Identify where data reading stopped. Are you trying to propose a feature or like what? What is that? You didn't stream for like 5 months. I see. Okay. Okay, anyway, so right now I'm going to work on a very specific feature which is called casting. I was explaining before you joined, I guess. Casting, like in other languages, let me just show it again. When you do like an like I don't know, you can cast like a string into an integer, right? That would probably like parse it. I don't know, like I'm not sure if I want to have like specifically casting strings into integers, but this also is an extensible operation. That you should be able to like define your own casting rules, similar to like Rust's from trait, for example. Right. Another thing as but yeah, like the main reason I want this in the language is because I want to have something like traits in Rust or type classes in Haskell. So the full syntax in Rust is having like type as trait colon method. Right, so this if we like look at this, then this TS trait is basically the same casting operation where you cast the type into a trait. The language that I'm making is treating types as values, so it's not really different than casting an integer into a different type. So I need this like generic casting operation. Just suggested a new console logging functionality to apply if you're making them from scratch. I don't understand the suggestion though, to be honest. You want the number of lines processed to generate console log error identify when the data reading stopped. I don't think that is supposed to be a feature of a language. This is something, I don't know. Where the data reading stopped. Like, so first of all, there is data reading, which is like some API to read data from where? From file. So that's just like a standard library file system, like API. And then if you want to like track how many lines have been read, that is not zero cost. So you actually want it to like be optional. So I don't know, that's just part of the library thing anyway. Language models often struggle to generate accurate error messages for the code they implement. How is the number of lines of code processed have anything to do with error messages? You mean error message for the code is like the compilation error message? Or what? How does that have anything to do with the amount of lines processed? That is like completely irrelevant. The amount of lines have nothing to do with like the code. All right, anyway, so I mean, feel free to explain your idea better, maybe. What's your native language, anyway? You say you use AI to translate. Macro cast. So I need to implement casting here. Maybe outside my understanding. Well, you could help me to understand your idea because I just don't understand it at all. Telling your ideas to other people is a difficult thing. Like if I wanted to tell someone else what's the idea of my language, that's also a difficult thing. After explaining it maybe like 100 times on stream, maybe I have become better at it, but it still is really difficult, you know, to explain why the language should exist like this. But feel free to give up on me if you don't think I will ever understand your idea. Alright, so in order to cast, I need a value to cast. And a value to cast, and a target to cast into. I want named arguments to this macro. Value and target. This is always going to be a expression. So I'm going to assert that the compiled type is an expression. So we need to have a new expression, which is a kast expression, right? Where value is need to compile the value, and target is file target. I think that's it. Kast value elemental magics. Hello, hello. How are you doing and your game? Today I implement casting for my language. Kast. Re-implement, because we had it before in the OCaml version. Written a long time ago. Was it a long time ago? When did I start my language? Like a couple months ago, right? I don't even remember. Finally casting in kast, yeah. Wondered why is that is called kast? There's a lot of reasons for it to be called kast, but also I was not the one who came up with the name, so originally the idea was different. But the fact that the casting is the most important operation in kast is kind of cool, I guess. But that's a coincidence, because originally the name was just, I think, QVMN and AST, because we were working on ASTs only parsing when the name came up. Yeah. Casting was not implemented back then. And Nigel, who came up with the name, probably didn't know that I'm going to have a casting like that in the language. per kast data. Could you, this is part of the statement. You have found out that if you define emojis as infix operators, you can make highly pictorial code for the game's content. Yeah. Fun fact, you can do that in my language. I'm pretty sure you can use emojis as operators. And you can define them as infix or postfix or whatever. As you want. This basically updates a bunch of states which are identified with pictures. Yeah, I think this looks to me like the builder API. So since I'm writing Rust here, I think usually, let's have function foo here. You say something like, you know, like stats builder new, and then you say like dot I don't know, stars 1, you know, dot health 4 and dot attack 0, right? So like something like this is literally what it looks like, and then you just replace this with emojis. Yeah. Sure. I think I would not do that in an actual programming language. I would not use emojis for anything, but I don't know. Like I would personally prefer something like this. So like instead of a builder API, I would do this in my language, right? Like I would do like I don't know, stats, and then I just have like the struct with like fields, you know, like health 4, you know, attack 3, right? And this is going to be like an anonymous struct, and since we have like compile time reflection, this could be like automatically converted into the same like builder API. Anyway. Expression kast. You can do that as well, but it's more lines of code and you have a lot of content. Well, I mean, technically, this should not even live in the code. This should this should live in the like in some data files. I don't know what would I use. I mean, we use like for some things I use TOML files. For some things I use JSON files. For some things I use Rusty object notation files. I don't know what's like the default serialization stuff for like Haskell. Is there like a serialization library like Serde for Haskell where you can like easily convert into like any into any format basically? There should be, right? Like if you have a lot of content also, maybe it's better to have an editor instead of writing that in code. I don't know. Kast value target. Yeah. Expression data. And so what's the type of this? Well, the type of this is the value of this thing here. I need to evaluate it here actually. Okay, I guess the target that I'm casting into should not be an expression. This should be a constant. This should be a value actually, not an expression. And then the type of the result must be the target, which must be a type. You do something like that, it's a bit tricky if some of your content is normal functions which are not represented as data. Yeah, yeah. Yeah. The main reason I think I'm doing this as serialization files is because of the compilation times. How is the compilation time for your project in Haskell? Haskell is like faster to compile than Rust for sure, because it uses the dynamic dispatch heavily, as far as I understand. Doesn't monomorphize the shit as much as Rust does. But whenever I upgrade, I don't know what it is, but like sometimes I upgrade my system, and the longest thing that I need to wait for is the compilation of Haskell. Actually, some Haskell stuff is being compiled on my system sometimes. I don't know exactly what it is, but that's what I'm waiting for. A couple of minutes max. That's a long time though. We're talking about like incremental builds. So you are working on the game, you change some code, and then you like want to run your game again, right? That's if you rebuild everything. Yeah, like what about incremental like changes, right? You don't like rebuilding everything doesn't really make sense. That's also like a couple minutes max for me if I do it with Rust. But like, for example, I need to wait in my current game like for about 30 seconds, and 30 seconds is like a lot. I mean, it's not a lot, but like it's kind of a little bit annoying. I can change like the linker to make it faster. I don't know. There's like annoying stuff there. 10 seconds is still like a lot, I think. But yeah, definitely better than Rust. I mean, I don't know. Like it depends on the size of the project too. Because whenever I just start a new project, the compilation time is just 1 second, or like less than 1 second, and then it just grows and grows and grows and grows forever. Guess I'm going to clone it here, I guess. So this over here then is not compiling the target, but evaluating the target, because I need the value here that I'm trying to get into. This is not necessarily a type, right? Yeah. None. Okay. So hold on. That's not entirely it. So this over here, this is not necessarily a type, is the thing. The thing that I'm casting into is not necessarily a type. Sometimes it can be a template. So this can be like a generic type. I guess I'm going to say here. Say what? I'm going to match target, and if it is a template, Let me consult my older version of myself and see how I did it before. This was actually an expression. Not a constant. But I was then evaluating it immediately, I see. So yeah, it doesn't matter. So the thing that I'm casting into can be a type or it can be a template, basically. And if it's a template, then type T is I'm calling the template with a value, which means that the value is going to be known at compile time too. What do I define as template? Let me show you an example, I guess. So like, how do we parse integers, right? In Haskell you have type classes, right? In Rust you have traits. In kast you just have a normal thing. So what is like a thing that defines how to parse type T, right? Parse. So parse is basically a function that converts a string into the type, right? So it's a function from string into type T, which means that this is a generic thing for all types T. No? Basically. Short version of this, right? This is probably like a new type and shit for all. I think the for all is actually a good. I like the for all. I don't know why you hate it. It's short. It like, I think it's understandable. It's English, you know. Scrams in normal programming languages speak. Nothing is normal though. Everything sucks. So basically, when you want to parse something into an int, right? You would say like int32 as parse, and then this is converting the type into like the specific implementation for this type. So I want to be able to cast into a template, right? This is specifically a generic type, I guess. So this gives me the function of type. So the result of this is string into int32, basically. You might prefer writing for all when the alternative is for all is hidden, and then mysteriously I cannot get imperative type when you use it wrong. In Haskell, when you define a function, you can use like the variables that are not in scope yet. You can write an explicit for all in Haskell to introduce these new variables, right? Explicitly, and I only want to support explicit introduction of these variables. So there is no alternative to hide it. Like, there is no reason to hide for all. The only way to hide for all is when you call a generic function. So if you had a generic parse function, right, you can explicitly make it like what do you call them in Haskell? I don't know what you call these in Haskell. The arguments, parametric arguments. What do you call them? I have no idea. But in Haskell, the syntax is at, I guess, for like doing those explicitly. In Haskell for all silently at the top of the type. Yeah, that's what I'm saying. For me, it's going to be explicit everywhere. There is no silent for all anywhere. At least not yet. We'll see if I'm going to introduce it. I don't think I will, though. Anyway, that's what I want to implement. So, like, casting a type into a generic type. This is technically substituting this t with this int32. Basically, so it's instantiating the template with this value. To get the type of it. Which code editor is this? This is NeoVim, NeoVide, to be specific. Front end for the NeoVim with animations. In productivity also breaks type inference everywhere if you use it. I don't think in predicative types. Let me look this up. In predictive polymorphism. I mean rank-n types. Rank-n types is yeah, sure. Like that's going to just be there by default in kast. It's not specific to types like in predictive polymorphism, GHC will only instantiate a polymorphic function at a monomorphic type. One with no for alls, for example, ID is for all B, BB, foo is ID run ST, rejected. The definition of foo is rejected because the one would have to instantiate ID's type with B, and that is not allowed. So you are only allowed to instantiate a polymorphic function at a monomorphic type. Okay, I see, I understand. And this like extension allows you to have this to be anything. I think I just have this by default because like I'm not special casing anything. So this type for me is just the same as any other type. What's the language compiler's favorite holiday? Bugsgiving. What's the first rule of programming language design? If it works, don't break. Is that true though? I like breaking things. No. Breaking things is good. Or I guess not breaking things as is like stop them from working. Breaking assumptions is good. And trying something new is good, I think. Especially when you talk about programming language design. What's the reason to just do something that already exists? Haskell is a book with 7 seals for you. Sometimes you need both imperative types and also no monomorphic restrictions to actually use things. Productivity allows me to pass lenses around and store them in data structures which you need for your game logic. Yeah, I can see that, but also kind of weird. You will be able to do that in kast, but I'm not like guaranteeing that so like the interpreter will support that, but when I'm going to compile the language into other things, probably not everything is going to be supported in every target, like storing a lens. We'll see. We'll see. I don't know yet. Value type. I reveal. Can casting to target type is not possible. Mm -hmm. 100% you can KMAT proof your language. I don't know what that even means. KMAT proof. Commit first. There and back again. Semi group. I don't know what you mean by that. So yeah, I'm not sure. So anyway, so the easiest thing is when I have just a type. In this case, we just do this thing normally. And if I have a template, then type down. The command is the guy who made all the intense category theory libraries like control lens. All the amazing kast libraries, somehow like 50% one guy. Grandmaster. Here's my Code Forces profile. Movie man. I was Grandmaster at one point too. I was almost international Grandmaster at some point. These days I'm just a master, I guess. I guess I did not really participate in and like increase my ranks since 2016. But I was a Grandmaster 10 years ago. I don't know. So what I want here is, if this is a template, then competitive programming. Yeah, competitive programming. I did a lot of that in like, that was a long time ago, I guess. 10 years has passed, huh? Target. So if it's a template, do I want to like convert my casting operation into something? Or do I just calculate the type differently here? I might just need to calculate the type differently here. In order to do that, I would need to evaluate the value again here, right? Go do some rounds on Code Forces. I have an idea that I should do some competitive programming with kast, with my language here, you know. So like technically the goal right now that I have, the short-term goal, is to make the language usable enough to do the advent of code. Advent of code is not really like competitive programming. This is like the easy thing, relatively, I guess. But I want to do this in my language, basically. Time to pick up Nutella. I don't think I can get to Nutella, though. Like, especially since like 10 years have passed since I was last doing my embedded programming seriously. What is this? Novice Grandmaster Master. Nice. Okay, so in order to like figure out the type of the casting, I need to match my target with these things. It's either a type or a template. Other things are not going to be ordered. This just type, I guess. So in case it is a template, then I need to call the template with the value. So I need to evaluate the value here, right? Value. Yeah, is my expressions clonable? They are. Sure, I'll just clone it here. Also, in case of a template, I should probably like not evaluate this twice. To do not evaluate twice if template. See that? Got pretty good at computer programming back in grad school since you taught algorithms. Down, down, down. What's grad school? Like so here we just have school and then we have university, I guess. What's grad school exactly? It's a college. So is like is college and university the same thing for you guys? Higher education, which awards postgraduate degrees, masters and doctors. So it's like the university then, right? Yeah. You're gonna enjoy computer programming now as a way to practice advanced Haskell techniques. You can install the entire program as the type at the type level, etc. Yeah. I tried Haskell for computer programming at some point. It was hard. Maybe these days I would do it easier though. There was some performance issues. Mostly though, not the. I mean, the way you write Haskell is like completely different from the way we do computer programming normally in C++, I guess. But I had problems with performance. You got a master's degree, which is a 2-year program after you have undergraduate degree, which is a 4-year program. Okay, yeah. Okay. Yeah, we have like the same thing, I guess. Just called something differently, maybe. I don't know. You made a prime numbers generator in Haskell. It was slower than Ruby. Can it be considered an achievement? Well, you wrote a program in Haskell. That's already an achievement, right? Not a lot of people can do that. Let value is kast evaluate. So I'm going to evaluate the value here. And then I'm going to instantiate the template here. Cast. So template is what? This is a function, right? So cast whole function template with the value, right? That is the result type. So I just do type expect to be type. I think that's it. Value needs to be borrowed, sure. Which means that I don't need to clone it actually. But I need to do that here. That cast is cast enter scope. As a good post goes into using type families, type class, and template Haskell as 3 different ways of doing compile time evaluation. That is to use compile time computation and cache the answer to all possible inputs at compile time, then solve the competitive program in a constant time. We haven't thought of embedded programs as much as a way to compete and more as an object of study. In other words, you don't take the task entirely at face value. Yeah, makes sense, makes sense. Makes sense. But I don't really like that. Like the fact that you can do that, compile time, like using type families and type classes to do like compile time computation is weird. I think that there should be just a proper way to do compile time evaluation, like Zig or like I'm doing here in Cast, where you would just be able to run any code at compile time directly. Another language that did that it was D language. Because otherwise you can do like C++ templates are also Turing complete, so you could do anything there too, right? During compilation time. It's like programming in brainfuck. It's possible, but I don't want to do that. I mean, it's not as painful in like Haskell, I guess. You can do like similar stuff in Rust too. Yeah, template Haskell is like where you just run code directly. Yeah, why I did not, which is why I only was complaining about using the type classes and families. Template Haskell. I never tried that, but yeah, I understand what it is. Does it operate on ASTs? Does it give you AST of Haskell program? Or what does it operate on? Not sure, you're a beginner. Well, it's either AST or like intermediate representation directly, and I would assume that it is AST. Or does it like give you like a way to like query the compiler? What is the type of this thing? That would require more than just AST, I guess. It could also be done with just tokens. For example, Rust does templating through procedural macros, which just operate on the tokens. So like on the just the lexer is the only thing that is fixed in. You don't work with ASTs, just with tokens. All right, now I need to evaluate the casting. All right, let's see how do I do this. So first of all, I will say value is evaluate the value. Right? And then I need to cast it into target. Um, so what I'm going to have is I'm just going to have a map somewhere. Did I complete Factorio? No, not yet. But I decided I should like switch back and forth because Factorio takes too much time. I'm going to stream both. Do I have a PhD? No, I don't have PhD. I'm a dropout. So I didn't even finish the pre-PhD stuff. Um. All right, so here's how casting works, right? I have a value and I have a target, and I will literally just have for now. I will have a map which like just binds two values together, right? So I have that somewhere. Let's see, inside the interpreter. Sure. Let's see. So cast arc mutex, of course. Of what? I'm going to have a. So it's not like a hash map from like tuple of two values. So the value that I'm casting from and the value that I'm casting into. Albrainoid. But it's something very similar to that. Into just a different value. That's it. Casts default. So I can do here self interpreter casts lock and wrap get for value and target, right? Yeah. How are you doing, Raynoid? Some result, then I just return result. If it's none, then casting not implemented for these types, I guess. Most successful dropout entrepreneurs. Yeah. Sure. At some point, I'm going to finish cast and I'm going to be another successful one, right? Is there, wait, hold on. Is there any successful person who made a language, though? How do you even make money making language, right? Because that's what successful is, right? Getting Baratro's UI reworked, hired an artist. Nice. Smetagate exists, but I do not implement the hashing, right? So that's why I cannot get it here. So how do I do hashing? So the values might be types that are like that are inferable too. I can implement a hash maybe. Maybe I just implement hash directly. Do I? Let's see. I think I'm going to have a different thing though. No. Let's do this. Casts. Let me have a cast map. How about that? I will have my own cast map here. And I will even move it into its own module. Module cast. Struct cast map. Use cast that. So instead of get, I will say something like cast cast value into target. There you go. That's what I'm going to need to have in my API here. Cast map. So public API is function new. Right, I'm just going to derive default here, something, and then we have the public function cast self. I'm casting value into a target, and this should give me an optional value. There you go. Suyash, hello. Unrelated, but do you know what arrows are? Generalization of monads. I think I heard about them, but I did not dig too deep. Arrow versus monad. See if I can understand it immediately. Monads are arrows equipped with an apply function of this. Applicative functions have a wide variety of applications. The short answer is arrows are more general than monads and are also more cumbersome to use. Town. I definitely have like seen that before, but monads are arrows equipped with an apply function of this. What is another example of arrow then, other than the monad then? I guess would be my question. If it's a generalization, what would be another example? I moved from a camel. Yeah, I did move from a camel. I'm using Rust. Moved twice, maybe more. Well, I did move to Haskell first for just a couple of days before I rage quitted Haskell. And then we just use Rust. Rust I'm comfortable with. OCaml is an okay language, but it still is annoying in my opinion. Rust is also sometimes annoying, but at least I'm used to it. There's going to be one more rewrite into the language itself at some point. Kast is also annoying with its for all. Well, that's like you are the only person who's complaining about that though. You are literally the only one. So for casting, we need to have two operations. First, I need to like implement casting, so like introduce a new way to cast things, and then I need to actually do the casting, right? let's say that like the cast map is like already like defined somehow, which is going to be like I don't know. Let's just have map. It's going to be a hash map from ID into I think I just do a hash map ID into values. That. So I need to convert values into their IDs. That's what I need to do. Which means that ID needs to work for values here. Do you have an exists as well? A lot of people complain that Haskell doesn't have exists, even though you can encode it easily. I don't have it yet, at least. I don't know what. But I can. I mean, maybe I have exists. I don't know. Like when I like yeah, I don't know. I don't know. You mean so exists would mean existential types, right? So in Rust that would be something like an impl trait, I think. That's what you mean? Existentially quantified types. Washing a group of types into one single type. That's nothing different here. Not yet. I think I will have them. So the only difference between that and just being the type being inferred is that I should not know details about the type. Like at least if we compare it with the impl thing in Rust. So you have some like some constraints about the type, but you shouldn't know the exact details about the type. So like some type exists that satisfies these constraints, and that's the type we're going to use, right? For now, I can just infer the types fully. I also like don't have like a ways of hiding other information. Like I don't have privacy at all right now. Like fields of my structures are always public. Everything is public right now. I will need to have visibility at some point too. With 95 tests, you have a function coverage of 96 and a line coverage of 80. All right, but what does your program do except for tests? It's printing pretty tables. Nice. So I need to get IDs of values, right? So self map get for value ID and target ID. I guess I just make these methods and then I clone it, and that's my thing. So I just need to make sure that I have the IDs for values. Sure. I mean, or I can, instead of like doing the IDs, I could do like my own like hashing stuff. Kind of. So what's the std ops d hash we just have the hashing there because it's like it's very similar. But then I need equality too. You have equality kind of. Value. Let's try this. Let's try if this works. In OCaml, I was using IDs because like if you use a hash table in OCaml, you cannot overwrite the way it computes the hash, but in Rust we can. And I need to not derive this thing here. I will need to implement the hashing manually here, I guess. What are the default values? Hash slice? Doesn't matter. Okay, so if I have the hash, this encodes the discriminant. Yeah. Nice. Yeah, sure. And then I'm going to match self and make sure. Well, discriminant doesn't actually like make much sense. Eventually I will have the inferable thing here, so I think let me have a to do here. To do careful with infer, which I just don't have it right now. Only the types can be inferred in this implementation. Boolean value, and then I do value hash int value hash. So this is very close to the standard implementation, but I think in some places it's going to be different, like for the bindings, for example. For the bindings, I'm going to instead hash the pointer, not the contents of the arc, right? So I'm going to say arc as pointer binding, and then I hash that. Can I just do that? Tuple. Okay, that can just be done normally. Function. They use kast yet? I mean, you kind of can, but it's easier if you don't do it yet. You would need to still implement some things manually, I guess. You can fake exist with a data end-to-end for all. And if you have one of those, it's the mysterious type which you don't know about. Yeah. Yeah, makes sense. Tuples implement the hashing, right? Yeah, they do. Typed function is a function type plus a function which has ID. I think I just do the same here though. Template. Macro. Why do you have a to do that says be careful? It's for me later when I introduce a new variant here. This is not going to be correct anymore. Discriminant will not be correct anymore. Waiting until you can rewrite your card game in kast. Nice. There's like a couple big features that need to be implemented. One of them is casting. Yesterday, or like last stream, I did the algebraic data types. Then there is going to be contexts. And then something else that I forget about. I mean, all of these are technically going to be the same. Multiset. Huh? ASD. Syntax module. Okay, I will leave these to be to do actually. I will leave some of these to be a to do. The ones that I care about are the types, basically. Change crabs to cats, cause casts like mascot is a unicorn, so the crabs are going to be converted to unicorns, I guess, not to cats. Hash. Okay. A function. I don't think this can derive hash, can it? Bitbound function hash is not satisfied. Yeah. So I will need over here to do this manually. Implement std hash for native function. This would hash the name, hash the type, hash the implementation, but this is going to be arc as ptr. It's pointer. Okay. It's almost like I want to like implement my own arc, which is going to like have its own hash and equality. I want cats. All right. Damn. Nice. I thought that was a cat for your game. Oh, it is in your game? Alright. You said you hired an artist. I thought all your art was done by Spacey. Is it not the case anymore? Or to just use existing art that you had before? Okay, here's what I'm going to. Then I will be able to hash it to be derived too. I think that actually might be a good idea. So instead of arc, I'm going to call it I don't know what's the thing. It's going to be a reference counted, which I don't know. I don't know what to call this thing. I'm going to call it a park. I don't know why. Because it's a pointer that is atomically reference counted, I guess. Yeah, sure. I will not use the arc anymore. I will instead have a module for that and use that. The arc, the kast arc. I don't know if that makes sense. Maybe. Does no one like who is written Rust ever needed a map where you would like store as keys the like the arcs that should be like keyed by the pointer and not by the value that inside the arc? So something that is not hashable or not comparable, but the pointer can be comparable, right? I have needed that multiple times. There's probably like a crate for that. Crate, Rust, crate, arc as map key. Mappable RC. Is that it? Provides a mappable RC and arc implementation. Described by two types. So they call it mark. Okay. Maybe that's the thing that I should call it. Corresponding to the RC and arc and RC types. For the most types, these types are near drop-in replacements. They also provide shared ownership by reference counting, many of the same methods and almost all of the same trait impulse. The key difference is the existence of the map method on both types. For example, MRC map is this. No, this is just mappable. No, that's a different thing. That's not what I want. Not final, but here's the current draft. Iteration. I don't remember the old version and how it corresponds, but these are my current like items that I have. The font is a little bit hard to read, but I guess you don't need to read it more than once because I read this as scare, not as score. All right, I will have my own implementation. It's fine. Create a module park. So I'm going to have struct park t, right? Inside, it's going to be just an arc. You know, that's it. So import arc to the sync. Literally the same thing. I'm going to implement clone for park. I cannot derive this, so I need to do that. And I also need to implement equality for park. So equality is going to be different. It does not require equality for t. It just says that it just uses arc pointer equality of the cell 0 and other 0. Then I also implement hash for park. And this is not hashing that thing. This is going to hash arc as pointer self 0 dot hash into the state. Something like that. So it's cloning, equality, and hashing, and then also I implement deref, ops deref for park. And the target is just t, right? Let's say 0. I think that's literally it. That's all that I need. Park. Cache. Park. Just use park instead of arc everywhere. I think everywhere. I mean, some of these is fine being just normal arc, but it's fine. Yeah, I need to have a new method, right? Impl t arc function new value t. This is self arc new value. What I can do, I mean, I just want to like go through these things. I can like just rename it as arc and then like rename it back or something. But I will go through maybe somewhere it does not make sense to use it. But I think I can just use it everywhere. Yeah, this for example should be just an arc. Maybe. Let's keep it a park. Down. Are we casting today? I am changing the Rust's arc into my own arc, and I call it Park. Don't ask me why. Definition clone. Okay, so over here, this is I should maybe have an into here. I should clone to arc. So I should have impl t. I should have from arc t or park t. Self value. Okay. Try wrapping this expression in park. I can delete that then. Hello there? Hello. Hi, hi, hi. So yeah, you see how like for equality I was using arc pointer equality, and like it's almost like I don't need this to be manually implementable anymore. I think I can now just derive this. Think. See if I will have a bug because of that or not. Partial ack, and hash can be derived now. Mm, maybe compile the fan is a park mutex option park. Sure. The binding. Expression binding. Park. 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 Is it the same here? No, this is me making these to be same. But now I can just use if A is equal to B, because equality is the same as pointer equality. Now, Park does not implement debug. Okay, so I need to implement debug for this. Implement t cdfmt debug for Park. I just say self 0. That value e is self value fmt f. T must be std debug itself. Just waiting. Sokoban made in cast. I think the first game that I make should be Sokoban. I thought it would be Asteroids and not a Sokoban. Or Pong. Maybe it will be a Sokoban, we'll see. Debug, not display. Yeah, there is like two different things. There's both debug and display. What I need here is just a debug. I'm not even sure if debug is needed. It's just I'm using it for some reason. So definition here is this. Definition clone into. Definitely Pong, but a circular one. Like we play on a circle, or you mean like everything is a circle in our Pong? Sure. That actually is probably even easier to implement than normal Pong. If everything is just a circle. Let's not load the arc at all. Arc. Yeah, I already have this. I have the ref map, which is literally doing the same stuff. But now I can just make it a hash map. You know why it looks so smooth? Why can't we have a terminal offering this kind of render sugar? Because not every program in terminal will look nice with that sugar, I guess. Even if in Neovite here, I will open a terminal, then I no longer have animated cursor here. Because it doesn't look nice for everything, I guess. But maybe if programs could like enable them, like if they could opt in, like making it an opt out is not an option. You can only make it opt in then, so that some programs would. But then programs need to be written so that they like need to opt in there. I don't know. Takes up some RAM, which you're not ready to give up. I'm not sure if that uses a lot of RAM here. Especially compared to other things that you have on your PC. Just don't import the arc.
Oh man, I keep forgetting to cancel this.
Pigorly. Hello. Yeah, thank you, Pigorly, for forgetting to cancel this.
Cancel doesn't have a hello.
Um. I can also like make it transparent, like it literally cast the references to arc into references to park, because that's just like a simple wrapper by transmuting. I don't know if that can be done like safely there. I need to implement default. Implement default. Default. I guess I just default can be derived here. Derive default. You hate stupid Microsoft. What did Microsoft do to you this time? Oh, well, deck. Okay, here's the problem now. Arc in the Rust standard library is special cased. And I cannot have the same special case for my own thing. Because if you can cast an arc to a concrete type into an arc to dynamic trait to din trait, right? So how would I do that? Is it even possible? Like, what's the difference? Is it special cased actually in the Rust compiler? I think it is, right? Arc. Hold on. Rust cast arc to arc din trait. Like, can I have the same but for me? Where is it implemented for casting? Din trait. This function ignores the metadata of the din trait pointers. I don't think I can, which means that um do I have like a dedicated constructor for that though? Let's see. Let's say that I have function from u is type u. returns into self. And to do self arc new u as arc p. So like I cannot have the constraint where it says that this is usable, right? A non-primitive cast, as expressions are only used to convert between primitive types or to correspond to a specific trait object. So this is supposed to be a trait object, but a trait cannot be a generic argument. Oh my god, Rust is such a bad language. Do you guys know that? Cannot write the thing that I want to here. I mean, I guess I can like construct an arc and then convert it manually. Someone should make a better language. Yeah. I guess I do park. Okay. So over here I will just do like specific arc, the sync arc new, and then dot into. Like that will work, but now I need to specify more types. Function type, I guess, like that. Maybe trade bound. Gina the potato, hello, hello. You like crab? We also like crab. Trade bound. Parked in FN into result from arc closure. Okay, so here you go. Like, because okay, the type inference also is really bad because I need to make an arc with the concrete closure type, but this closure type needs to be casted into a din trait. And I cannot cast it into a din trait in the constructor of the arc because that would be an unsized type. So I need to cast it after I construct the arc over here as std sync arc underscore. That will figure. No, this says cannot infer the types. Okay. Okay. So what is this anyway? Let me call this a native function impl. I will have this as a type alias here. Type native function impl is this. So I will have an arc native function impl. This needs to be public, and also it needs to be like without the thing. This is the unsized type, and this is park, and then I get the arc. When we were at the beach this summer, I went down to the water really early in the morning and I saw the cutest little crab working on his little burrow hole thing. Very dedicated little dude. Nice. Arc syntax definition from park is not there. Okay, so I need to like have the other one. So I need to also have impl t sized into arc t for park t, right? Which is going to be like just self 0. Okay, failed to resolve more stuff. I just say A is B. A is B. A is B. I might need one be able to derive the partial equality for type then too. You've never seen someone make a programming language before? How is that going? I know nothing about making programming languages. I'm just doing as I feel like doing it. You know, maybe other people do it better, but I do have something that's working. You know, I'm kind of happy with what I have. And how the language is shaping so far, but it's very far from being something usable. The plans are huge to be the best programming language ever, you know, and that's a difficult task. There's a big scope to this project. I think I just derived hash here. And then the types need to be deriving the hash too. I think variant type needs to be deriving hash, sure. And then so over here I have the so the type might be and not yet inferred type, and in this case I think I'm going to need to say something like I should not be able to hash the not inferred types. Impl. Wait, but it's also going to, okay, if I derive hash, I'm pretty sure that it's like doing the discriminant and as part of the hash, which is going to say that inferred string is different from a normal string type. I feel like I need to split the type definition into two different things. I think I need to have enum inferred type, or like, I don't know what I call it, like concrete type, and this will have all of my like types that I actually have, and then the type is in either an inferable type or like something else. Where did zero sized type go? I mean void? Well, void is unit now. I thought that's what you wanted me to do. Unit is correct. Might rename it back. Now that you say that and you make me think about it. We'll see. So basically, the types and like values in this language, like are potentially not really inferred yet, right? I can make everything a variable actually. Maybe. This is like such big changes that I'm doing here. Yeah, and like it looks like in this case I can also derive debug clone partial egg and hash here. So what is a type? I'm just going to say that a type is just inference variable of the which is going to be inferred into the inferred type. Maybe that's all I really need to do. Maybe. So my plants in the background that remind me that I have a small snake plant on my shelf. I had forgotten it was a real plant because it hasn't died. But it hasn't grown either. Should really water it. It's been like 9 months. I don't know what a snake plant is either. I sure it's a plant. It's been 9 months and nothing happened to it. Does it bite? I'm scared. I'm deleting code here. I'm scared what I'm doing here. Maybe I just make a new type here. I don't know. We'll see. Let's start by making this. Now let's make a new type. Struct type has the inference variable inside. I will do this. Bug clone. Implement hash for type. So this is going to match self 0 get. Get exists for inferred type, but its traits were not satisfied. Wait, what? Inference variable as get where it's inferable. Okay, because inferred types need to be inferable. So inferable for inferred type, right? There you go. There you go. So I just match AB here without this. And this is something that I don't do anymore. This should not have type. Everything here, type colon colon, is going to be substituted with inferred type, right? And what? And I return OK. Inferred type doesn't implement display. Display for inferred type. Okay, actually over here, inferred type is going to be just self. I think self is making more sense to use here. And like here. So inferable variables are not part of that anymore. FMT exists for tuple, but the type doesn't implement display. Yeah, so like we have like I'm splitting the type into two different things: the thing that is already inferred and the thing that is not potentially not inferred yet. Display for type, right? So this is I'm going to like match self plus 0 get. Right, if it is some inferred, then I write, then I just do inferred fmtf, and if it's none, then I just write f not inferred, right, like this. Equality is not implemented for type. This, in case it's none, I'm going to panic right now to do. So like, since this is panicking and I want to catch it, I cannot override the hash so that it like actually like is returning an error. Use custom hash trait maybe later, but if it is inferred, only then I can hash it. Right, yep. And I implement partial ec for type. Partial equality is basically I'm going to match self get and other get. We have these things. If they are both not inferred, well, I mean, these are like variables. I think only if they are both inferred, actually. Then I say A is equal to B. In any other case, I should say that self 0 is same as other 0. You like code? Are you welcome? Sure, yes. You're making a new programming language? Yes. Can you tell the pros and cons of its current state? Well, the cons of the current state is that it's not implemented fully. The pros is that it's the best programming language ever. You know? Right, let's see. So here's a website that we made. It's not the best website. It's just the first revision that we quickly threw together. So I guess the killer feature is that everything is a value. So which means that you can do anything with anything. You have seen, so it's really important because you want to run your code at compile time and manipulate your types and other things at compile time. If you have tried Zig, that's what you can do there, right? You treat types as values. That's what it means. Okay, you can treat a type as a value and like perform actions with your types at compile time, which means that the compiler itself is technically an interpreter. Okay, and then you can do like by manipulating ASTs, you can make like AST-based macros and stuff like that, right? So that's like the thing. Also, one of the features that is important is the context of functions. This is the closest feature in other programming languages are algebraic effect systems, where you can annotate your functions with what they can do. So if your function can allocate, It's not just a function. Not everything can allocate. Only those functions that are marked with requiring an allocator will be able to allocate. Only those functions that are marked with the fact that they can panic or throw an exception, I guess, which is the same thing technically, is going to be able to do that. So whenever something can happen, it should be explicitly noted in the type system, similar to like how like Haskell is doing it with the monads, but a different thing. It's a little bit different than just the algebraic effect system, but that's the core idea. I want to code as much as possible in the type system, and then we also want to have compile time, comp time evaluation, which means that compiler is an interpreter, and then also we want the language to be extensible. So even things such as syntax is not fixed, but syntax is implemented in the language itself. This is the standard library syntax, which is defined in the language itself. There is no built-in syntax, and if you want to, you can extend it. Implement your own operators, your own other syntactic constructs. Fully made for real-world usage. Yeah. I am personally interested in making games, so I'm going to try and make games with that. Right now I'm just doing some technical stuff. But the end goal for today is to implement casting of values into different things, which includes casting types into traits. Impl equality for type. Deallocate self. Associated item type is not found for the struct. Yeah, so that makes sense. That is all very different now. Get the actual variable if it is an inference variable. This is so now all the types are always inference variables, I guess. So inferred would give me inferred type, or a reference to the inference variable of the inferred type. I'm not sure if that's needed anymore, but sure, let's do that. This is always inferable variable, I guess, so I just do this. Variable is just self0. Okay, or self0. Make same would be inferable make same. Self clone and other. Sure. Expect variant. Okay, so expect variant, expect template, all of these things I want to have implemented on inferred type, right? Only those things can be variants or other things. Expect error, inferred type. Try to make it a programming language with free AI tools online, but failed. I don't know what to tell you. I have not used a lot of AI tools myself. I'm not interested in AI. I think AI is stupid. I would expect that AI should be able to make a simple language like, I don't know, like what? I don't know. Like it can read books, right? And then copy paste from there. Like whatever you make in the crafting interpreter's book. Lua. Yeah, Lua. Yeah, I was just trying to come up with something even easier, like something with even less features than Lua. Like a small Lisp, I guess, right? Because I think the smallest examples of languages that are being made are usually Lisps. So inferable, so these are now, so this has been unreachable, and now I'll no longer need it. Okay. And then we also implement inferable for type that is not inferred yet. And if I need two things to be the same, then I say self dot. I say A 0 make same as B 0. And then okay, A, because those are just the variables, I guess. Yeah. Use of moved value B. Wait, where is it moved? I mean, I can get the reference to AB so that I don't need to move it. I can also clone these things here, maybe, because I don't care for now. Substitute type bindings of a type. Okay. This need to be type is inferred type. Okay. Value expect type. Expect type should give me a type, yeah. This should return type. Yeah, I do need type as a result, which means that this should be like type from that. So I should be able to construct a type from an inferred type, right? Type like that. Let's see, impl from inferred type for type. This would be self. So since this is a variable, inference variable, I just make new and then I var set to value. I return the variable. Return inferred type. Mismatch types. Expected type found in inferred type. Type is inferred type. But yeah. Yeah, because I need the original type here. So I will, I guess, say that this is inferred. So I'm cloning not inferred. I need to clone the original type here. And this should be inferred variant. I guess I just use into here. Make type from, or I can use just dot into. Just found another bug with unit tests. Downtown. Um, that's nice. Good for you. Imagine if you would not even write bugs though in the first place, so that the unit tests were not necessary. Imagine if something like that was possible. Into. Infer is something that doesn't exist anymore. Yeah, there you go. Oh my god, so much changes. Unit tests have bugs. Like unit tests for unit tests just to be sure. Actually, like believe it or not, but I have been writing tests, and that's what I have been doing. So like one of the things that I have right now is a test. So over here, this test exists for the sole purpose of making sure that other tests actually testing things. And they actually don't test things right now, so this thing is being ignored because the tests are actually not testing things other than just like running. But I'm supposed to like test that the output of a program is a specific output, but that's not being tested right now. Only the fact that it doesn't like panic while being interpreted. But yeah, eventually this will be a test for tests. And I will stop ignoring it. Just need to have a way to redirect my output to something that I can capture. Type. New new not inferred. Let's have this constructor. Function new not inferred. That would be a self inference variable new. No way, there is no more warnings. Just all of them are gone like that. No, never mind, there is more. It was just thinking for a minute. Eval AST. Expected type is some type. Okay, so now I should say something like inferred type dot into, right? Now I should be doing this. Inferred type dot into. Inferred type syntax definition into. Inferred type unit into. inferred type into type infer is type new not inferred instead. Inferred type string into inferred type function into type infer. This is just type new not inferred. This is a placeholder, I guess, to do not necessarily a type. Infer variant type. Go into. So I guess I need also need impl from inference variable for inferred type for type. As this will be a self value. Biggest associated type, inferred type. This should be inferred. This should be a type new not inferred. Okay, type clone, expect variant. At check, this should be check for the inferred type. Okay. Result type is type new not inferred. Type boolean into type into type multiset into type unit into type tuple into type syntax definition into this is inferred type. Inferred, okay, type, match type, yep. Sure. Also in the syntax definition, inferred. It feels like weird, but the fact that I can just work like that, make a huge refactoring and just fix all the errors is actually really nice. Right? This should be inferred type. Inferred type, inferred type. Inferred type. I had the same with OCaml and Haskell. Yeah, true. I did have the same with OCaml and Haskell. Though my problems with OCaml and Haskell are different. That works the same in both Rust, OCaml, and Haskell. Yeah. Do you have the same in your language? You're writing TypeScript still, right? Because I think in TypeScript, I don't remember if I don't remember how TypeScript was, but definitely not the experience with JavaScript. Oh, you're writing Dart now? No way. From what I looked when I looked in Dart a long time ago, I think it would not work like that there. But I don't remember anything actually. Type new not inferred. Infer type tuple into. You write Dart for the whole for the rewrite. So you're rewriting your tests in Dart, right? And showing tables, pretty printing tables. Nice. Infer variant. If you're trying to build type, consider the following associated functions. Type tuple. Inferred type tuple. Type AST. Inferred type AST. Type dot expect inferred. Maybe I will have another thing. Function expect inferred type, which is going to be inferred type result. This would be self 0 dot set to type. Inferred type AST to inferred type unit into. This is not make sense. This is gonna be like expect inferred. Inferred type tuple into. Inferred type function into. Inferred type template into. Inferred type unit into. Expect inferred type unit. Map or type unit, previous data type clone result type. Map or else. Inferred type unit into. Type is type new not inferred. Expect inferred type string. Type new not inferred. Inferred type unit. type new not inferred. Inferred type function. Expect inferred. Low gauge. How are you doing? Expect inferred type. Insert type. Insert type. Let me have over here inferred type. Value type. Type bone into. Yeah. You got a bunch of Adderall, so you're basically as smart as Scooby now. Be careful because I know a guy who was using too much Adderall. I think it was called Adderall, and then they eventually got a the allergy to it. I don't know how it worked exactly, but like they were using it like all the time, and then eventually just like instead of working and making them smarter, they started to have like side effects. Um, you know. Expect inferred. Inferred type function. Ooh, mismatched types. Expected. This found struct park closure. Okay, that now I have the same park issue. So this would be std sync arc new, and then I need to cast it to std sync arc native function impl, and then I convert that into park, right? Annoying. Okay. Inferred type string. Inferred type unit. Expect inferred to inferred type function. Same thing here. Sync arc. I guess I will have to do it more times here in the future. This is the native functions. I have like 3 more of these. Technically, this is like almost like copy pasta. Maybe I will like rewrite this later to be shorter. Native function impl. 2. Type new not inferred Function type is well, those things. Result, inferred, type boolean. Expect inferred type function. Same shit. std sync arc. New as std sync arc. A function impl into. Type new not inferred. Inferred type tuple into. Expect inferred type. std sync arc new as std sync arc native function impl into. Okay, that's the last one. Type and new not inferred. Inferred type tuple into. Expect inferred type function. std sync arc new as std sync arc native function impl into. All right, we just have 1,000 more errors. What is this? Inferred type. Okay, cast value into target. What is this? Target is a value. Okay, target value into target. I mean, sure, I can have this as a reference. It doesn't really matter though. We'll clone it here. It doesn't matter. Type variant. This is inferred type variant. Value type. Just going to make this to be not into, so this is a type. Definition clone does not work because definition here is definition clone into this. We convert it into a park, right? Park syntax definition. Definition is park syntax definition. Okay, but wait, no, over here I need to have a an arc. Right? Maybe just don't even need that. Why do you not compile then? Because definition is park. Yeah, because I need to do dot into here. There you go. Inferred type int 32, inferred type int 64. Expected does need to be mutable. Function typed function is not hashable. This can be hashable now. Partial ACK hash can be implemented for those. partial egg hash. Inflicting the implementation of egg. I'm just making it based on ID, but I guess it doesn't matter anymore. AST hash is not satisfied. So you need to like hash an AST. Let's have AST value then. I'm going to have a new type, derive clone partial egg. Wait, does it mean that AST? Hold on. Struct AST value. It just has AST inside, right? Or I guess I could move the park into a library. What's an AST? It'll just debug and clone. It does have the yeah, so like over here I also am deriving the equality. Instead of deriving it, I'm having my own implementation and I'm doing arc pointer equals. I can just use the park here then too. Pretty sure. Yeah, that would be much easier. I should just use park here. Move that into the what? Into the util, I guess. So park moves from here to here. Lib mod park pub use create park web park. Let's see, and the AST and use park now, and I need to use park, which means that I should be able to do easily partial egg and hash to be derived. This implementation is no longer needed. Let's not even import arc then. So this should be instead park. Syntax insert. Do not import the arc here either. This should be park. Okay. Into arc for park. Replace implementation with from park. Wait, can I implement from? There's I cannot do that. Can I? From park for arc. I guess I can, because the generic argument is my type, or what? I don't know. Whatever. So AST, no AST value anymore, just AST directly. That's fine. Okay, back to this shit. Expect type, self unit. No, this is a value. Value is a type. Inferred type unit dot into binding. Inferred type binding. into Factorio. Redeemed waste points. Fuck? What do you mean Factorio? The fuck? This is not Factorio. Why am I not playing Factorio? I don't know. When I'm playing Factorio, you can ask me why am I not working on this project instead, or on other projects. There's a lot of things that I could do technically. Why are you not making your own programming language, and why are you playing Factorio right now, King, huh? That's the real question. Everybody should make their own programming language. Get the type over this value. Inferred type unit into. Inferred type multiset into. Inferred type boolean into. Inferred type int into. Inferred type int64 into. Inferred type string into. Inferred type tuple into. All right, let's do this. Substitute type to inferred type. Function. I guess I need to do that into everywhere still. Too lazy for that shit? Are you not too lazy to make mega factories in Factorio? I don't know. For me personally, making a mega factory, that's much harder than just working on some cool programming project. It's almost over, it's almost over. We just need to fix 100 more errors. Wait a second, this does not show me any more errors. Useless conversion into the same thing. Yeah, because this is now still park. No longer need to do that. Consider removing dot into. Yeah, sure, I will consider removing that. Rewrite it in Rust. This is what is happening on the screen right now. I am rewriting my project in Rust. I am technically doing the things that I have done before. In OCaml. And I'm doing it in Rust now. Although the end goal is to rewrite it again and not into Rust, but into itself. You do OCaml? Well, not anymore. I don't like OCaml. I think Rust is a much better language. But OCaml is okay. What happened to OCaml? I don't know, it's just annoying. I got annoyed of like the way, so like my program here, like I guess it's dependent on the project. My project here is very recursive in nature. So like just to like it's just like small organizational issues, I guess, mostly. Like I want to split my code into multiple files in order to do that and to split it into different modules, but my modules are very recursive. Making recursive modules in OCaml is a huge pain. So I ended up like utilizing like functors for that and like making like some stupid shit. I don't know. As like one example, I think that's really bad. The lack of traits and the fact that I need to do everything with modules in OCaml is kind of bad. I think that traits or like type classes of Haskell are much better. You can do the same thing, but you need to repeat yourself a lot in OCaml. Was it the tooling? Yeah, the tooling also. Yeah, language server absolutely sucks. That's also why I dropped Haskell. Haskell's language server is actually even worse than OCaml's. I guess compared to OCaml, compared to Haskell, OCaml's language server is really good. What's bad about the LSP? Do I want to remember what was bad about the LSP? Does anyone else remember what was bad about the LSP of OCaml? Or do you want, like, because I remember more the LSP of Haskell, because I tried that after OCaml. I don't know, it was, I remember that it was crashing all the time. That's one of the things. It was literally just crashing. And I also remember the entire code being like underlined with red. Even when there was like one small error in one place, it highlights the entire code with red. It sometimes was showing me fake errors. I'm remembering now. Yeah, it was showing me the errors that actually didn't exist in the code. I remember it. Yeah. New is never used. Whatever. Allow that code. All right, let's see. REPL. Is it? Did I break? Like I changed like 1,000 lines of code, or even more than that, maybe. Let's see. std print hello world. Okay, this still works, so I didn't break it completely. But what did I do? I was making the casting, right? So we can so like A is B is still like being parsed properly, okay? And if I say, but I should not be able to evaluate it yet, right? If I say hello as std int32, this will say casting is not implemented, right? So casting is not implemented is casting is not implemented over here. No, wait, what? Not implemented over here. So this is when I'm evaluating the cast operation. It's because yeah. So casting Value into target. Not implemented. Use moved value kast value whatever. We just clone everything. Okay, I mean, or I can like get the value back here. Okay, error value. Maybe this casting operation, if it fails, it should give me the value back. So I will have like result, value, and value. You know? And I will clone here as an implementation tail that hopefully will change later. Cloned, okay. Or one as std int 32. Okay, so yeah, see, so casting 1 into type int 32 is not implemented, right? So now the next step would be to make the conversion rules. So that was done by okay or else. Yeah, there is also okay or else. Yes and Are you asking something? Standard library. Although except. Okay, we can start with something simple, like implementing type name for types, right? Can do that. Std lib over here. Let's say const type name is name is string as type. I guess this is the first thing that I need to do, because like, so I have this anonymous struct, which is a value where the field is a value of string, but this is a struct, not a type, which is struct, not a type level struct, but a value struct. If led got some stuff. Okay, so yeah, let's try this. Cast this as type. So I think this one is going to be a little bit different. I'm going to match target. And if it's value type, and then if type inferred is okay, inferred type, right? Then allow Clippy, allow single match from Clippy. So in this case, I will just do value.expect type. Expect. I don't know. Something like this is the return, okay. Well, I guess, okay, I guess, return value clone expect type expect error. I don't need to clone. I need to map error value type value into. That's what I do. No, type from value is not done. Expected result value and found type. Yeah, because expect type is giving me a type as a result, but I need to map the type into value type. Map into. Can I just do map value type? Right, like this. Trade bound type from value is not satisfied. E value is expect error. Value is value. Type error. I guess I just give the value back. That's what I do. Makes sense. Extrapol. All right, let's see. So now I should be able to cast. So for example, this is when I just have the brackets like this, right? This is a unit value, which is type unit, right? So unit value and unit type is like similarly looking things, but they're actually different. But if I convert this into a type, then this is going to be a type unit, not just a unit of type unit type, but a type unit which is of type. Does that make sense? That does, right? Okay. So similarly to that, a unit type. Well, there's a unit value and a unit type. Yes, a unit value is a value of type unit. So unit is technically two things. It's a value unit and a type unit. And similarly to that, there can be other things. For example, I can have tuples, right? So tuple hello and world. So what is this? This is a tuple hello world, which is type string and string, right? But what if I have a tuple of like std int 32 and std string, right? This is a tuple which has two types, right? But what if I want to have a type which is a tuple of an int and string, right? In this case, I can convert this into a type, and this would be a type which is a tuple type of integer and a string, and that is a type. Does that make sense? It's like very similar. So similarly to how this unit and this unit is different, the tuple of types and a type of a tuple is different things. Do we have HKT yet? Almost. Let's go further. As std type is basically like infer in TypeScript. It's not infer, it's convert. As is a casting operator, where you cast something into a different type. So the type of this is a tuple, where both fields, the first value is the second value is a type, right? So the type of this is not a type, but I want to cast this value into a different type. In this case, I'm casting this into a type. So it becomes a type, which is a tuple type. Casting, get it? Yeah. So types as values. Yeah. We get types as values. That's what I'm. Literally. That's the main thing of the cast language. functions, types, templates. So like you probably like know what does like treating functions and as values mean, because basically every language has that, right? But like treating types as values is not very common. The like I don't know, the currently popular. Yeah, you've written some Idris, yeah. So like Idris like does the same thing, right? By treating AST's values, we can have like AST-based macros, which are like written as normal code, and they are not anything special. Like in Rust, you need to like do a macro rules, which is like a separate language for macros, or like procedural macros, which work like completely differently too. For me, everything is just going to be normal code, basically, is the idea here. Yeah, I'm wondering if I can do like in Idris. I did not write any Idris myself, but like I wonder like the dependent typing, right? Is the Idris's thing? We need to like be able to write proofs, right, or something like that, to have dependent types, right? Yeah, I need to like look more into that. Maybe I should actually try writing Idris one day. There is also other things that I want to look into. There was what I think I have been writing things down. There was dependent types. There's also refinement types. I'm not sure how like those are different. We saw like liquid Haskell, which is different from Haskell. I think they also have something similar. Yeah, there's like a lot of things that I could look into still. You are not a type theorist. Yeah, I'm also not a type theorist. I'm actually like not a theorist at all. I know no theory. Absolutely, I'm making a language without looking into any theory. So like, I have implemented the type inference, which is which as far as I understand is based on the Hillner-Milner. But have I actually read what Hillner-Milner is? Only briefly, like for like about 5 seconds, I have looked at the wiki page. But I think that's what I have here. Right. I'm mostly making a language based on my experience with other programming languages. You can create a type for vectors of length n with n is a value. Yeah. Yeah, although right now, yeah, I mean, yeah. Yeah. So in Rust, that feature is called const generics, where your generics arguments don't necessarily need to be a type. It can be any value. So for me, it's, I guess, the same, where I am making a generic over here with the for all keyword. This says t. In this case, is being inferred to be type, but it does not have to be type. It can be any value. It can be like an int32, which so that's how you would do a const generic. You just make your generic argument to not be a type, but anything else. And then you would be able to create a type, which is a fixed sized array. Yeah. And then we should have inference. The inference should also work not only for types, but for any values, because everything is treated the same way. So yeah. I have also been showing this every time. It also is like an interpreter. Everything. So compiler is the interpreter. I can assign the things that are not yet inferred to like to variables, and like this thing is a not inferred type for now, but as soon as I like use it and in some context that like makes the type inference like algorithm work, right? Like when I say that this is of type please infer, this obviously means that please infer must be a string. So like after that it is being inferred to be a string. And yeah, if that makes any sense to you. All right, and then we do casting here. So now I want to over here. So now the way I'm doing traits or type classes is also by casting things, but in this case, so this is how we cast into a type, right? This is implemented inside the interpreter itself, but I also want to declare my own casting rules. So when I cast like int into a type name, the result of this cast operation should be where name is int32. So this is very, very simple trait which does not use like the type of itself, I guess. So this is just me casting like that. This is how I write an impl block. std syntax. Did I maybe create impl? Yeah, there you go. So previously it was impl trait for value as impl, but I think it makes more sense to me to say that that value as target is equal to the implementation, basically. I think that makes more sense to me. So now I need two different binding power. Yeah, let's have 4. Okay, so now I need to create impl. Create define. I will call it define casting. Or I don't know, implement cast. Impl cast. So impl cast, we get value target and impl block. So I think the easiest implementation for now is to just compile this to just nothing, and instead just do the side effect immediately during the compilation, like creating the casting rule. Right, so I say that value is evaluate the value. Target is evaluate the target. And impl is evaluate the impl. And then it says self interpreter casts lock unwrap. I don't know if is this part of the interpreter or part of the compiler. I mean, those are the same thing technically. But I want to implement cast of a value into target as impl, right? That's what I want. Just implement cast value target impl. So this is technically very, very, very simple. All I need to do is I need to do self map insert value target and impl. This is a very, very simple implementation for now. I also must like technically check that the it's the correct like type wise. But let's see. So if I use std star, if I say int32 as type name, then it's going to say not implemented. Okay. Implement int32 as type name as is high. Int32 as type name high. Okay. Why did it not work then first time? Because this is literally the same, right? This was done in stdlib. It means that this was not done because this needs to be part of the compiler after all, and the compiler cache, which is like shared between everything. So because I'm making a new interpreter sometimes. Let's have a mutex here. Yes. So it's not interpreter, it's going to be compiler. Casts. No, it's cache. Compiler. Cast no longer necessary. Cache compiler casts. Right, let's see again. If I do use std int32, no, I use std star. I don't have these specific usages yet. Int32 as type name. Okay, there you go. So this is the simple thing, and then the more complex thing is if I wanted to have an actual trait, like if I want to have a trait parse, right, which is going to be a template instead, type. So self in this case is going to be the type that I'm implementing this trait for. And this should just have the parse function, which is the string into self, basically. And then I implement int32 as parse to be equal to this thing where parse is, I guess this is a type, right? I need to do this. Wait a second. How did it work even before? Parse. I guess when I cast something, I always expect it to be a type in the end, so it doesn't matter. But technically, I should like convert that thing into a type. We'll see. Anyway, so parse in this case, I will implement this in the interpreter, so native parse. right? Over here, this is going to be inferred. The type of this is going to be inferred to be of type string into int32 because I'm implementing this for int32. So the way it works for when I'm doing the implementing the casting rules for templates like this, the template argument is substituted with the value of the thing that I'm implementing it for. And that means that it does not need to be a self, and I can like have a tuple here, and that will be the multi-parameter type class easily. Native parse is not found. Interpreter. Let's have a native parse function. Parse. So parse is a thing that takes a string and returns the type that I actually pass there. So then the actual type that I'm parsing into is function type result inferred type must be known. Function type. So if this is okay type, then I match type. If it's error, then going to fail sync and parse not inferred type. So if the type is an int32, then I will return a value int32 of argument. So like my argument must be a string, as expect string, right? S dot parse question mark, like that. If it is anything else, then iReveal type is not parsable. So this should technically not compile. So int32, int64. XTD in, sexually transmitted disease in. Hello Raymarch, how are you doing? I'm just trying to see if I have if I can have traits again. I'm still rewriting my OCaml stuff into Rust. I have a couple features left to implement. One of them is casting. So if I say use std star int32 as parse, like this. So this is a function now, string into int32, right? Although this technically is string into int32 because I have specified it here. I don't need to specify this here. This is supposed to be inferred. And I'm pretty sure the inference is not working right now. So int32 as parse is not inferred. So the reason it's not inferred is because I need this value to be of a specific type. So the impl type must be the type of casting value into target, right? So impl type impl type. I mean, technically, like I can before evaluating AST, I can compile it, the implementation, right? Before evaluating it, and then I say that implementation is evaluating that. But before evaluating, in between here, I will say that implementation type needs to be inferred. This is an expression. And this needs to be inferred into the kast target. Template. So it's like this thing technically. You're about to reach your weight goal. Once you do, you'll have the ultimate cheat day. I had pizza today. You want an R ligature that makes the R very tiny and maybe raised so that the focus is on the ident and reading. What do you think about the raw identifiers in kast? Because the way I'm doing it is I'm doing it with the @ symbol. This is I think they did it similarly in Zig, right? So you do @ and then you just do a string so it can have a space or whatever symbol inside. But it also like makes it highlighted differently than like the thing. I guess like highlighting depends on the language mostly. But yeah, it's just like a string, so it's parsed the same as a normal string, so you can have anything inside. And then it's just the identifier that way. Expected once, argument found 0. Expect inferred. So I want something, something, something. I want this to be value is an expression. Okay, I guess for now we'll just copy paste kind of. I mean, it's not a lot of code, but no. Hold on. Like, how would I do this? I need something like I need like kast dot kast result type. Kast result type. So I'm casting into target, right? But my value is not necessarily always needed here, so I'm going to provide that as a closure. If I need a value, then I'm going to say this kast dot enter scope dot eval value for a weight. So that is what I need to do. And is so valuable. Array at 4 for indexing. Struct at field. Reads so easily. You don't like the dots? Why do you need struct at field instead of struct dot field? Read above. Above what? Oh wow, that's cool that it can have space. I wouldn't sacrifice a symbol like at for that though. At is so valuable. Array at 4 for indexing. Struct at field. Reads so easily. I mean, the reason it reads easily because you read the at as at, right? So array at 4. Like, do you really want to spend the at for identifiers? Here's a better question if you want to talk about the syntax. So I have changed the syntax of my language a little bit here. Here's a question. Like this. Here's a question. I changed the syntax of the language where I specified the tuple. So like tuple, which has like hello and world, right? This is two values, hello and world together. This is normal tuple, right? And then if I want to have the named field in addition, so previously I would just say like named colon value, right? But I instead now use dot named is value, so that this is a named field, this is a named field, right? I think that's okay. I think that's okay. But yeah, also like this means that if the value of the named field is the same as the name itself, then I would just be able to do dot named, you know. Yeah, and then I also have like this the sum types, right? So I have a option which is sum or none, right? So here's what I do now. I do sum 1 to 3. This is option int 32. So I use a colon to specify that this is a variant. So in Rust we don't have any syntax, any special syntax for specifying that it's a variant constructor. And now I use this. I was using the dot sum before, but I need them to be different, the two syntaxes. Like, but I don't like the colon here, really. You think the at symbol makes sense here for variant types? At sum 1, 2, 3. It is one of the few symbols that can read that way. Yeah, but like the dot still is fine, I think. I think the dot is better. It's like smaller. Because at is like like the problem with at, even though it reads easier, is that it's big and it's like when you say like one word and then another word, this like from the distance, this looks like one word to me. So when you have like a dot, this is a much smaller thing, and that helps you visually separate the two words. So dot is better in that case. So yeah, but I need something here for like the variant construction. I also have like anonymous variant, so I can technically do like A, and this is the variant A of some not inferred type. Does some infer the type? No, it infers the type based like when you specify the type. Might have like anonymous variant types too. We'll see about that. So if it's never inferred, then it would like merge all the use cases and construct the anonymous type. Then might be useful sometimes. Or like you might like inline your variants in the function definition when you have a function which returns like OK or error, you know, something like this to like specify this inline there. Right? Yeah. I mean, I can already do that. Swift has that. Yeah, I'm just like wondering about the question is about the syntax mostly here because I'm not like fan of this colon because I think I want to I don't know. I think it would be nice if I would replace this double colon for specifying the types to be just a singular colon because specifying the types is something that happens like very often, and I think a single colon is better than a double colon. What do you think above? You wrote with underscore. You wrote above with the underscore. Underscore full bar. Yeah, so like I was thinking about that. Wait, hold on. What is underscore full bar? Hold on. To be honest, I don't fully understand why round identifiers need extra characters that are not part of the existing identifier characters. Like, why cannot not be this? Well, underscore is a special thing. Well, I mean, I guess I could like if it's I can make that if I see an underscore and like the lexer can see if the underscore is like followed by the quote, then that would be the row identifier. Yeah, maybe. I don't know. Is that better? Maybe. But yeah, it should just not be confused with underscore space string because that would be a different thing. Underscore is like the automatically inferable thing or a pattern that matches everything. Because underscore is already part of identifiers. Maybe. You know what else is part of identifiers? Hello world. I think dashes are also a good part of identifier, right? I think we talked about that before, but what do you think about this one? Kebab case best language, yeah. Right, anyway, let me go back to this thing. I think like talking about syntax, we can do that forever. I think we will eventually come to some conclusion of what to use. I change it. So I literally changed like the syntax for the fields yesterday and for the variants, and I'm expecting to change syntax more in the future. I agree with your underscore 12 point though. Like you already, so underscore 12 to make 12 into identifier. It's similar to dot is easy on the eyes. Yeah, I agree with that. Yeah, I agree with that. Yes, at is a little too noisy. Yeah, maybe. Is there like another symbol like this? Well, I guess the plus and minus would be confused with like unary minus, plus, equal. Yeah, I don't know. There's also like the backtick. You know how like there's also like this thing where you could like do a backtick. That's what they do in like SQL, for example, right? That's another alternative. Although I really like the fact that it's like parsed as a string, so I just need some prefix before the string, right? So I don't know. Could be like back quote and then string then too. Backtick is too valuable. Right now my backtick is the quote operator, which is quoting the AST. so I can like see what is the AST that I'm parsing my code into. But I can still have it to be used for both, because for quoting I also need the for quoting I need a backtick, and then I also have the expression that I'm quoting in parentheses anyway. So I could have it for both. Because technically, like, I'm quoting. I don't know. Is like row identifier kind of similar to quoting? No. All right. Anyway, what was I doing here? Casting. I need this to be self dot cast result type. Let me for now comment this. Cast result type over here. I need to uncomment this. I need to move that there. Simple cast function cast result type. So I have value, which is impl fn once into local into box future, I guess. Of value of every result, then value, and then target is value, and this should be itself async, and then we return IRE result type. It's gonna be a salad of lines at the top. You just don't want to read this. Yeah. I don't know. I mean, it's like a row identifier is something that is supposed to not be used very, very often. So I don't think the syntax of that matters too much. I might just change it when I will want to use the @ symbol for something else. I just don't use it for anything yet. Underscore foo. Yeah, maybe. I'll keep that in mind. What did I just do? This one? Yeah, this one. Is it not compiling? It's not fn async, it's async fn. That's why. Anything else? It still is not formatting. -4 is -4. Yeah. Yeah. Although negation of a string is probably not going to be implemented, but yeah. Like technically, I can never mind. I'm like I'm going to try finish my code for now. That's a library feature. I mean, yeah, it is a library feature because you maybe will be able to implement negation of strings as a library for sure. It's not going to give you it to give it in the standard library. Where is the syntax error? I don't see it. Over here, yeah, over here I want kast result type, value, and target is value. There you go. So yeah, we match target, self, enter scope, and then value is value weight. A expected result, return OK, like this. Also, you kind of like hello world idents because in Rust it was a dumb gotcha where the crate name is foobar but the code is foobar. Yeah. Yeah. I like to working with a kebab case in Nix. Like over here. Here's my dependency, and I just use it as an identifier in my code here. It would be cool if the LSP would catch situation where hello world is written, but the idents hello and world are also in scope, and say if you want to subtract, you need to add a space. Yeah. LSP is not going to be here for a while though. I still did not even look into how to start working on it. Did I wait? Question mark. Return value dereferencing. Okay, so we do async. Wait dot box. All right. And then kast result type. How do you do assignment? Colon equal versus less than. I do let A is equal to B right now. For mutation, I mean before my previous examples, the mutation was still just normal equality. So, or do you do the absolute brain dead? What is the equal should be used for? So like you propose to use the equal sign instead of the double equal sign for equality comparison. Is that what you're saying we should do? You did not say that? Okay. Okay, the result type should be future ready value boxed target Mismatch types. I cannot convert from type to inferred type. Yeah, because this should be inferred type. So I instead do make same data, and I need this to be immutable, I guess. Ready value. Ready okay value. Okay. Use of moved value because this needs to be cloned. Sure. Target also needs to be cloned. Look at this language. Look what I have to do because of reasons. This code actually does not look very good here. You're kind of annoyed at Winit right now. They have some stuff that could be expressed as enums, but is doc text and product types instead. If that you cannot do that. They're changing their APIs constantly. I think that you might want to like tell them and point them to the issue, and they might want to fix it, because a lot of like changes that they did in their API was to make it like a more rusty API, like have less things like that. So far, the people that I heard were complaining about Winit was about the constant breaking changes that they make so that the API is more uniform and more rusty, I think. Like, you know how they did the they completely redid the event loop like recently. I also had to change the code of my engine a lot. You don't want to annoy anyone? You think they're doing a Herculean task? Yeah, that's why I also never like very rarely submit an issue to public repositories. I just complain to myself and then just say okay and keep using it. Sometimes I make my own fork and fix it and make a pull request, and it doesn't get merged. And sometimes it does. I rarely open an issue. Speaking about the issues, no, never mind. It's fine. I just wanted to complain that I did a pull request and it got merged, but it never like got into crates.io. So I still need to use my fork, you know, because they just don't re-upload to crates. I'm kind of just venting, but deep inside, I'm grateful that Winit exists. I think Winit is fine, although I know I don't. I know like what is actually like better to use, like SDL or Winit. Sometimes I think it's SDL, but at the same time I was using SDL was a long time ago. I don't know. I just feel like more people use that, so technically should be better, no? I use std star 32 as parse. Okay, binding self. SDL3 has the whole thing about game consoles on the side. Yeah. Okay, so I need to also substitute the bindings. When I want to know the kast result type, I'm going to call this function calling template with a function. Wait a second. Wait, what? Hold on. std32 as std parse. Says string into self. std parse std int32. Yes, so like, okay, this is not correct. Wait, why is this so? Did I not do the things correctly? Just treble. Hold on. Const test is for all t. T. Test std. It's 32. Okay. Let's say t into t. Test std in 32. Okay, there you go. So it actually does not work. This keeps the bindings here. Why does it do that? Why does it do that? Maybe it's because the function type. How am I doing function type? Yeah, function type is a constant. So yeah, when evaluating, expect some type. None. Yeah, so like I'm evaluating it immediately. Sure. Interpreter constant value self substitute by bindings. I guess I'm going to match value type self substitute type bindings t value clone. Maybe this is going to make it properly. std int32 as std parse. Okay, there we go. Nice. Okay, so here you go. We just do std int32 as std parse, and then we do dot parse, and this is a function, a native function parse from string into int32. So then we parse 1 to 3, and this is going to give me an int 32 of 1 to 3, right? Okay. And then if I wanted to do that later, we could have a standalone function parse, which is parsing type t by saying t as parse dot parse t as parse dot parse. I guess that's it. Is this project to be completed? I mean, that's I mean, hopefully it will be completed, but like I said, it's mostly just for fun, but it's looking good, I think. Completed, we don't do that here. Let's see, std parse, std parse 1 2 3, explicit panic. Type 47. Panic. Yeah, okay, so not inferred things can... Okay, let's do this here. Not inferred type cannot be hashed. So, like, obviously this should not compile, because if I do... This is a panic because I cannot, like, take the... I guess I can do, like, catch. I can, like, catch and wind, I guess, to catch the panic. But I think I will just change the hash trait into my own trait, maybe? We'll see. But this is not supposed to compile because I don't know the type. But if I say that the type of this is stdint32, then there you go. Okay. Ugh. And then if I want, I can like parse this into an stdint64, but 64 is not implemented because that implementation is not here. So I can also say that implement x64 as parse. So that's going to be the same. I literally just do the same thing here. All the types are being inferred here, right? std parse 123 std64. There you go. I should probably like I kind of want to also have the floating point numbers. So let's have float 64s. Why not? While I'm at it. Let's have float 64. But this needs to be equal, so I'm going to... Okay. I want my values to be hashed. So I want the... How many games has Scooby actually completed on this stream? Plenty. Gems that count. You can say it doesn't count when somebody knows how to scope properly. Yeah. Well, I mean, we can also when is this project considered finished, right? If I have an interpreter that works and that you can extend with your own native functions, and you have type inference, and you have like templates, and you have like all the things, like it is a programming language already, right? So like, it's just like, when is a programming language completed? You know, like, is Rust the programming language completed? No, it's not. It's still evolving, right? If you can make a game with it, yeah. I'm just saying that technically the language is still like usable. I think I might like make it as a library, so I could actually you can use it as an embedded language, like a scripting language in your game. I don't think we needed to like make the entire game in this language. You can make it in addition to like Rust to do some scripting, for example, and that still is usable. Like, you know, like other language like Lua is used this way, right? You like 2 dialects, one for core, one for scripting. So the idea is that like this language is like going to be usable in all of these ways and without having different dialects. It's just different targets. Okay, I need a floating point number that is like ORed. We can have a noisy float, or I can use my own library. But let's just use noisy float so that I don't use my own stuff here. Rust analyzer health status is error, failed to load workspaces. Docs noisy float. Is this like the crate? Do you guys use any of these? So I want R64 for finite F64 values, basically. I don't want to support nuns in the interpreter, I think. Or like, I mean, I could like make my own, just Rust total CMP float. Like, I just need the one that is like like that. We have the total CMP in this standard library, but we don't have a new type for that. Ordered float, I guess, is the one that I should use, right? Wrappers for total orders. See the ordered float. Okay, so that's what I use. Then ordered float. Okay. And then we have the egg, ord, and hash. Let's have a ordered float, version 4. Number guessing game. Number guessing game is an example, and it already worked in the old Camel version. I think actually I might be able to do this. No, not yet, not yet. I mean, I can like get rid of this unwind stuff, and then we will be able to do the number guessing game already. This was just showcasing the unwinding, which might be unnecessary for this, just making it too complicated for an example, I think. But we had the number guessing game before. Use ordered float. Ordered. Ordered float. F64. Is that how you do it? Okay. Display value. Float 64 value. Value FMTF. Type of a value float. Bird type float. Type is to be float. When people tried in Haskell gloss. Two ghost. Hello, hello. Two ghost 2. Load 64 is not found. I need that in the interpreter to have in the built-ins. Bind this to a name. Load 64 is load 64. Right. So now I should also do std parse 123, which is float 64. So I'm parsing this. It's not implemented because I need in the standard library. Specify that load 64 also needs to be parsable. Right? std star parse 123 load 64. Load 64 is not parsable. It's not parsable because in the interpreter, the native thing also needs to be extended now. Over here, if I need to parse a float 64, then load 64 parse. Use std. Parse 123. Load 64. There you go. 32. 64. We have the plus function, or like let's see. If I say function foo is a function which takes a and b and returns a plus b, then this is a function that is not inferred. Okay. Yeah, because the plus is like polymorphic. Okay. I'm not like checking the constraints on my functions that like the arguments actually implement the traits that are required yet. That's like another thing that we should add. But if I say that foo is a function where a is int 32, then b would also be like automatically inferred to be int 32, and the result is int 32, right? So then if I say if I call function foo with something that like parse 1, 2, 3, and then like we also like parse 4, 5, 6, right? That's not right. We need to have two values, right, to this function, and call this function with two arguments. Parse 1, 2, 3 and parse 4, 5, 6. Not inferred type cannot be hashed. Why not? Why something is not inferred here? It fails to infer my types here? So foo is x int 32 x plus x. Let's just do that. Foo parse 1, 2, 3. Foo into std parse 1, 2, 3. Okay, so like this has been inferred properly. So is it do I have problem with tuples maybe somewhere? If I say that foo is x and y, and then I say x plus y, say foo std parse 3 and 5, that works. Okay, wait, this is literally the same, but if I say this std parse 1, 2, 3, and this works again, okay, wait, hold on, what's the difference? What is the difference? Maybe I have a bug somewhere. Maybe it's RNG. Is it RNG? Let foo be function a. Okay, I mean I also did use std star. I should have like an example here. Like let's do a simple example, I guess. Cargo test. Let's just test the things that I already have. Everything should still work, yeah? Yeah, okay. Let's say that test equals so here's the code. The code is going to be use std star, and then we say let foo be a function, a is int 32 and b is whatever. This returns a plus b, so it just like adds two integers together, and then I just call foo with parsed 1, 2, 3, right, and with parsed 4, 5, 6. This should be evaluated to int 32 of type of value 5, 7, 9, right? Wait, this worked. Wait, what did I do wrong first time where it said that it was something was not inferred there? What if I do this? Okay, that did not work. Expected int 32 got nothing. Wait a second, why is this failing? Oh yeah, because okay, no, I see why. Yeah, because I also cannot ignore any value. So because this function evaluates to an integer, but there is a semicolon after that, there is an error because there is a semicolon. This must be a unit type. So I'll have like an ignore statement probably. Okay. I don't know. I don't know what I did wrong. It seems to work. This seems to work. Git diff stat. Let's see. So this is just a tiny commit, 133 insertions, 500 deletions. Tiny change. Made casting. Just a small commit, yeah. Let's see any of the examples, maybe that don't work still. Can I do a monad still? We can try doing a monad. Do I have everything for the monad? We can try again, Nerdsoul. Remember we tried doing this very early when I didn't even have like the templates, I think. The higher kinded types. Let's see this again. So we want to start with a functor, right? So functor, this is the Haskell definition. Functor f, which specifies the f map. So functor. I will delete this and do it from scratch. Let's see. I'll use std star. So functor is for all self. So functor f basically. I think I require curly brackets now here, and then this needs to have f map to be a function for all a and b being types. For all a and b being types, let's just have this as unnamed arguments. This is a generic function. Hold on. We just want to have a function from a into b into f a into fb, right? I think that's what we want to have. I'm not sure if this is going to compile, because since this is instantiation, I don't know the type of this yet. So I kind of need to make sure that this is like a template, so like a function of specific type, which is like in Haskell, this is a specific kind, right? Functor must be always a kind, type into type, right? I think. So I need this to have in addition, I think. Can a functor be like anything, something else than type into type? I don't think so, right? But if I just try this, just run examples monad. This is going to say that 11 for all this needs to be in square brackets. Template must be inferred, yeah. So this needs to be known. I need to know the type of it, basically. For all f. I mean, maybe, hold on, maybe f can be just like, it doesn't have to be a template. I can make it to be a function, a compile time function instead for now. Like templates are technically like very similar to functions, but they are like like they have memoization, same invocation with the same argument is the same result, is the only difference. But I can make this to be a function of like type into type, right? That's what I can do. And then it just means that this is not this is going to be like FA, and then this is going to be FB. Wait, do I need to have parentheses here? I'm not sure. Binding F is not a function. Yeah, it's not a function. Hold on, just REPL. Let me see. If I say A into FB, this is a type of a function which takes argument A and returns FB. Okay. Yeah, this looks correct. So technically, we would just do this same as in Haskell then. But then what's the problem? The problem is that binding F is not a function. While evaluating call expression at example monad 12, line 12, over here, right? Okay, I know why. I know why. I actually looked at it earlier today. So my function function type. So whenever I have the function type, this is trying to evaluate. So whenever I see in code A into B, I'm trying to evaluate this and that in compile time immediately, although I should save it and potentially evaluate it later. I'll make it work. I'll make it work here. I just need a new intermediate representation node for function types. So it's not going to be a constant, it's going to be expression function type, right? That's a new expression. Where I have argument being compile argument, and result is self compile argument, like that. Right, so now I need to have a new thing. Here, which is function type, argument, expression, result, box, expression. There's going to be a to-do context, data, function type, function type, function type expression. Function type expression is going to be evaluated to this is an expression that constructs a new type. Data, expression data. So type is a type. Span argument and everything. So I need the argument and the result both to be types. So argument type expect inferred to a type. Result type is type. when I evaluate expression function type, then all I do is I say that argument is evaluate the argument. Result is evaluate result. So I return value type, which is function type. Function type. Function type has argument and has result, which means that both of these need to be typed like that. Okay, is that it? Use result. Let's try again. Expected string got nothing. Standard library 14. Wait, my standard library is no longer working. Line 14. Panic is string into nothing. Wait, what? (14) 31 to 45. 31 to 45. This thing. So I am evaluating the native panic here. This expected string but got nothing. Wait, what? Wait, what? No. No. Function type, argument result. Let's see again. Okay, it's because the result is I'm compiling argument again. There you go. I need to compile result. Should I not have a... Okay, because I used variables here. I should instead do that underscore is context, because contexts are to do. But I should have this warning. Okay. Compile result. That makes sense now. Amount function type, expected nothing at type. That's why you don't allow warnings. Yeah, I mean, that's why you don't allow them too much. I guess this was this allow was only about the contexts. Instead, you have 500 to-dos in your code. Okay, I think the problem right now, though, so I have this issue that I don't know how to do here. stdlib. So the problem is that this over here is a unit, but it's a unit value. When I'm compiling this code string into unit, right? I need to evaluate, I need this unit to be a type unit, not a value unit, you know? Like, normally you do as type here, right? Like if I do this, that would work. So I was complaining about line 14. Now this is going to complain about line 15. But I don't want to have a unit as type every time, right? I want this to be dependent on like the inferable context, right? So I need to change the way I'm doing units. Make unit over here. When I'm making unit right now, I'm always making a value unit, but that's not always the thing that I want. Sometimes I want this to be a type unit, right? Which actually means that I probably want to have I I probably want to have expression unit, a dedicated expression for that. I think. Does that make sense? So that this means that the actual value of that unit is going to be determined after the type inference made its work. So unit expression is the one that's making a unit, and that can be valued to one of the two things. Does that make sense? I had the same problem in camel version, I'm pretty sure. You counted actually you have 112. Wait, can you do the count? Count matches. Compiler 7. Wait, there's no way it is only in the compiler. Yeah, it's also over there. I guess that. Can I combine all these numbers together? Okay, well, it's less than 100 for sure. For me. Dun, 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 dun. I think you do dash I and then dash capital I. So that's all the lines with to do. Well, it still has like the new lines sometimes. But it's like 40 here. I think it's weird that the RG, the grep still is like doing the empty lines because this is a different file, I guess. I don't know. Probably there is an option for that too. You could use a normal grep to do, right? Like that. But then this also goes into my target. So it's like weird. I should use the git ignore. Currents connects with WC. WC doesn't count empty lines. Is that it? So the type of a unit is actually not inferred? Huh? I know. It's weird. Like, I think for a unit, it should be like defaulting almost. I don't have like any defaults for any types, but for a unit, if I don't specify the type, then it should default to be evaluated to a value unit, right? I don't know. This might lead to new issues since this is the not inferred one. But anyway, if I have a unit thing, then I'm going to say like, I'm going to match data type, right? Inferred, I guess, if it's okay. Inferred type unit. Yeah, if it's a type, then I return value type inferred type unit. Inferred type unit, right? If I have okay, inferred type unit or an error, then I return value unit. Error means that it's not inferred, so I will like default to the unit here. And if it's anything else, okay, other, then I just like panic here. Panic. I think I actually even panic. Unit, inferred to be not unit. But other. Is it going to work? Expected LHS not inferred, LHS not inferred, got type. Okay, now I have the same thing. Now I have the same thing with tuples. So whenever I have a tuple, ah my god, and to figure it out. Wait, how did I do this before? There's no way I did the same stuff before. Well, okay. Let's just try actually just to run Nix. Run GitHub. Oh, Nix run. Slingcast. AutoCamel version. So here's the AutoCamel version. If I say unit, then this was called void then, right? But if I say like use std, if I say int32 and int32, this is this int32 and int32 as type. That was also working, but if I say int32 and int32 into int32, does that work? It does work. Why does that work? Why does that work? First of all, in my intermediate representation, I did have the function. No, wait, hold on. Function. No, wait a second. Compiler, built-ins. Function type. Function type. Oh, function type was a function. Yo, Gage. Thanks for the raid. Thank you, thank you. How are you doing? Did you do something something big, something smart on your stream? Like like always. Oh, the dumbest thing possible, play Mario. Alright, it's fine. Sometimes you need to take a break from doing smart things and like do something dumb. Which I am about to do very soon. Actually, I was going to end the stream, but for some reason I decided to implement something else. Instead of stopping when I implemented the things that I already planned for today. Should have played Splody. Let's play Splody. Is there going to be a Splody 3D release? Is that why you're playing Mario to like like what do you call it? It's like a research project for your future game, right? How would Splody work in 3D even? I don't know. Like, could that work? You need to aim. You need to aim, but if you aim with like in an FPS, that's like a little bit too much maybe. No 3D. Okay, so you're saying that I should make Splody 3D. Is that what you're saying? It's because you're not going to do it? Um. All right. Just wait a little bit until I finish all my current projects. All my 1000 current projects. And we'll start working on that. So the thing is that this is just a built-in function, so I actually did not specify the fact that I need those to be types. I think that's literally the thing. Okay. I see now. I need to figure this problem. This actually is a problem. So the problem that I have is let me see, function type. Function type. Over here. So like you see how over here I say that the argument should be like evaluated to a type, right? And that breaks things. So if I comment these things out, this is not going to make the type inference work very well, but I'm assuming that this is going to do it now. So if I say unit into unit, this is going to be a type of a function that unit into unit. But the problem is that this is now checked at runtime instead of being checked at compile time. So the problem that I have is that if I say unit of type unit, that works. But if I say unit of type type, that doesn't work. I guess std type, right? Wait, hold on, it works. Okay, this works because I did the unit, right? But it does not work for like tuples. If I say tuple, like hello and world, right? Or I guess a tuple of std int32 and std string, right? That is by default a tuple of two types, instead of being a type of which is a tuple of two types, right? Because this breaks the type inference, but this should still work, right? So this expression should sometimes evaluate to a type instead of evaluating to a thing. So we have it as casting. Not inferred type cannot be hashed. And then I have some other problems apparently here. Let's run the example monad. Hold on, the monad example worked. Nerdsoul, hold on, we're onto something here. Let's do just the REPL examples monad. Monad. It's supposed to be like a module, right? Monad dot functor. Okay. Hold on. So what do we do? How do we like test this? We implement something to be functor, right? What's the functor? Like an option. So option is a functor, right? But option is a template, so like I need to have a function, right? So let's say const option function. Write a function that returns a functor. And use it in context of a specific one. Okay, how about an example? I think my brain is not working anymore. Arrays are also functors. I don't have arrays yet. Let's do an option. Option is t into option t. I'm going to do that. So if I say monad dot option std int 32, this is going to give me that. Yeah. Okay. So yeah. So like this, I'm just converting a template to just a function because I need to be able to specify the types of my templates. Otherwise. Arrays are also functors. So what write a function that returns a functor and uses this as a context of a specific one. What does that even mean? What's the function that I should try? I mean, I can just like try using the fmap, but add 5. Okay, yeah, add 5. Sure. So add 5 is so this should work for functor f, right? And this should be taking the functor f, right? So the functor itself, and then it should return f functor dot f map x into x plus 5. That's it. And then we do add 5, and I call it with sum 1, 2, 3, which is okay. This okay. I need inference for that because okay. But I mean I can do it. I can do it like that, I guess. I can make it explicit. No, this is not going to work. I think. Not yet. Template is not a type. 21. Yeah. Mm. 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 9 to 21 over here. I'm trying to compile this f as functor, and it does not work because template is not type. I guess it's functor, which is a template here, right? And it's not a type. Compiler, macro kast. Call function. Okay, I actually see the problem here, I think. This over here is a template. Yeah, so the result of a functor. So this is a higher order type. Like it's not just a generic type. It's yeah, it's a higher kind of type. Yeah, sure. So when I'm calling a function like this, when I want to see the result, no, wait, no. So I'm trying to like convert this into a type is the thing, right? So this is supposed to be a type, and this cannot be treated as type right now. That's the problem. Okay, I think we are going to like try this some other day. One day the monad is going to work, or at least the functor. Yeah. One day. Some progress towards monads. Okay, one day kast will be usable. I mean, it's usable without that shit. Technically, I guess. Alright, anyway, I'm going to end for today. I'm happy enough with the amount of progress that I did. I don't need to do it anymore. I'm going to take a break. This is taking too much like power from my brain. Um, let's see here. Pum, pum. Who is doing anything useful? Rust around. Written a simple game engine in Rust and Lua.
Wayland Core. Boom.
There's a Vulkan with Rust.
Open all that up. Oh no.
Alright, see you guys next time. Thank you for watching. I'm probably going to do tutorial tomorrow and then go back to cast on Friday. See you then. Bye.